All right, we are now going to start tackling this. How do we develop a meaningful understanding, first of all, of what a fraction is? So here's how we're going to do it. I want you to be ready. I'm about to show you something. You can't see it yet, but you're about to see something, and I want you to pay attention to what I call your mind's eye. That's like, think what's inside your brain. I'm about to show you something, and I want you to see it, and then pay attention to how your brain reacts. What does your brain think in the moment that you see this for just those initial, 5 seconds? What does your brain think? All right, here it comes. I'm about to show it to you. Be prepared to pay attention to your brain's thinking. Are you ready? 3, 2, 1, here it is. I'm still here. I'm just letting you pay attention to your mind's eye. When you see 3/7, what did you think? How did your brain process that? Be honest. I wish I could talk to you right now. I want to hear from you. When I've done this in audiences, for decades, and I'll share with you in a moment what I typically hear, but will you just make sure you know what you saw in your mind's eye when that 3/7 popped up on the screen? Now, here's what is very common. The first is I'm going to make this up right now. 80% of the people that I've done this with over the decades, what they see is what we call part whole. They see 3 out of 7. And when I talk to them, I say, all right, when you say 3 out of 7, what did you see in your mind's eye? And people will either say, well, I saw a rectangle with 7 equal parts and 3 of them were shaded. Or I see a circle like a pizza with 7 equal slices and 3 of them are removed. 3 of them were eaten. 3 out of 7. Something like that. They see this part-whole relationship, 3 out of 7. And that's correct. That is one way that you can interpret what a fraction is. But it's limited. Here's why it's limited. If children only, or if adults only conceive of a fraction like 3/7 and they think 3 out of 7, they think 7 parts, 3 of them are shaded, they think 7 parts and 3 of them are removed, then when you get to an improper fraction like 7/3, what happens? 7/3 then becomes 7 out of 3. Do you see the problem? I see a whole rectangle cut up into 3 equal parts and 7 of them are shaded. Do you see the problem? So 7/3 becomes a problem if all we have is a part-whole relationship. Or when we get to division, I know I didn't type this in the way we typically see division, but will you read this as 8 divided by 3/7? Read this as 8 divided by 3/7. Now, if a student's understanding of fraction is part whole, what they're thinking is 8 out of 3/7. How are we going to teach students meaningfully about fraction division if their understanding of what a fraction is only part to whole, as in out of 8 out of 3/7? How does that make any sense? So I'm going to say that's about 80%. You'll have to check with your own thinking right now. Where did you fall into that camp? Did you see something like an out of 3 out of 7 kind of a way? Did you see a shape like a rectangle? Did you see a circle? What did you see when you saw 3/7? But then a much smaller percentage of people see a ratio, like the ratio of 3/7. There's 3 boys for every 7 girls. And that is, and again, that's correct, that we represent ratios as fractions like that. 3/7 of the kids in the classroom are boys or whatever the case may be. And that's not wrong, but it's just incomplete again, because that implies a multiplicative or proportional relationship. We're going to get into that a little bit later. And the problem is this. Suppose all you're able to think about is a ratio of 3/7. It means 3 boys for every 7 girls. But then some kids will walk into a classroom and they'll see 21 kids. They'll say, wait, 3 boys, 7 girls, that's only 10 kids. How come there's way more than 10 kids in this room? Like they missed that multiplicative relationship that it's a ratio, not an actual number in the classroom. So that's true. We should have it, part to whole, ratio, part of the story, but incomplete. And then another one, this is probably second most popular thing I've seen, is when people have seen my 3/7 pop up on the screen, the first thing they think about is, I'm just going to divide 3 divided by 7 and get a decimal. So they're thinking, they don't do it, but they're thinking, grab a calculator and go 3 divided by 7 and get a decimal and forget about the fraction. How many of you fell into that camp when you just wanted to divide and get rid of that? And that's correct. You can do that. Part of the flexibility in fluency is we want students to think, depending on the context, part to whole. We want a ratio understanding. We want them to be able to convert to a decimal by division if need be. But if that's all they have, we're not encouraging fluency, and we have some of the problems that I've been portraying here. And so I asked the question, what is a fraction then? So here's where you got to pause the video. You got to pause the video and engage in this task. Like engage in it for a while. If I was in a classroom with you, if I was in a workshop with teachers, this would probably be a 20 to 30 minute task of people working collaboratively on this thing. Here's the task. Suppose this blue bar, I'm calling it a bar. It's pretty common in some of the curriculum. When we're talking with fractions, we call this the bar model, but it's a rectangle, I know, but this bar represents 3/8. If this bar represents 3/8, you're from that to build on to it to create a different bar that's equivalent to 4/3. Now, I'm not saying you just ignore the blue bar and just create your own 4/3. I mean, given that the blue bar is 3/8, you got to create what would be equivalent to 4/3. So get out a piece of paper, tablet, whatever you do, device, and just, you can make your own rectangle. Shade it in if you want, do whatever you want, but make a rectangle, and in your brain, record in your mind, or write it down, that that bar represents 3/8. And if that bar represents 3/8, you got to build on from there to represent something that would be 4/3. Pause the video and go do that. Man, I hope you paused the video, maybe for 20 minutes. How long did you persevere? How long did you endure this task? How long before the productive struggle became unproductive? Or did you get it? Did you figure something out? Let's see. Now, over the years of me doing this, there's all kinds of possibilities. I'm going to show you one. Welcome to asynchronous online class. I'm going to show you one, but in the classroom, imagine if I was in the classroom with you all, you'd all be up at the whiteboards working together in groups of 2 or 3. And right now we would walk around that room and we would see everybody's thinking. We would debrief it and work on it, maybe send you back to work to do some more thinking on this based on what you've seen. But I have to just tell you how the most popular way this is played out. All right, so here's how it goes. That bar is 3/8, right? Well, what does 3/8 mean? Even if you have an 3 out of 8 conception, what does 3/8 mean? Well, it means this. It means that that bar consists of 3 pieces that are apparently 1/8. This is a 1/8, this is a 1/8, and this is a 1/8. We have 3 1/8s. And I want to just emphasize here that at this moment, what people have done is they've taken the original bar and they've cut it up into 3 equal parts because we know we have 3/8. But then if we were in a classroom and people were working on this, I would ask this question to help fuel the thinking. I would say, well, if that's 3 1/8, well, where's the rest of it? Like, well, how many eighths does it take to make? Oh, well, 8/8 is a whole. Well, yeah, okay, well, show me the rest of it. And so there's 1/8, there's 1/8, there's 1/8, there's the 3/8, and then 4/8, 5/8, 6/8, 7/8, 8. There's 8/8. There's one whole. So if this bar is 3/8, then this bar is 8/8. It's one whole. Now watch this. At this stage, what people have, if you did this, if I watch people do this, I would call out that what you're doing at this stage is you're taking the original bar, cutting it up into 3 equal pieces, And then you're copying those pieces, 1, 2, 3, 4, 5, 6, 7, 8 total times to make one whole, 8/8. You're cutting and you're copying. Hold on to that thought. Now, if this bar represents one whole, you see what I just did there? Now this is just visual. I changed the shade just so you can see. You've now constructed 1/8, 2/8, 3/8. There was the original 3/8 right there. And then you made 4/8, 5/8, 6/8, 7/8, 8/8. You made one whole. And so this lighter blue also is one whole since it's the same size as this darker blue. But now I want 4/3. I want thirds. So I've cut it up. Notice the cutting again. I've cut the whole up into 3 equal parts. Each part is called 1/3. 1/3, 1/3, 1/3. 3/3, one whole. Well, how many thirds do I need? 4/3. Oh, I need to copy, cut, copy, get it? I need to copy that one more time. 1/3, 2/3, 3/3, 4/3. So if this is 3/8, then this is one whole. Then these are each 1/3, 1/3, 2/3, 3/3. I need 4/3. I need 1/3, 2/3, 3/3, 4/3. Boom. If this is 3/8, then this is 4/3. That's the thinking. And what this has done, when I've done this with teachers primarily, and also in MAT256, the reason I do it is because it unleashes the way of thinking that is really productive with fractions. Cutting and copying. What you did is you took a whole rectangle. Now, it doesn't matter how long you made this rectangle. Do you know that? You could have made the rectangle as long as you want. But once you made your rectangle and you cut it up into 8 equal size pieces. Partitioning is the fancy word. Cutting is what I'll often say. When you partitioned the whole into 8 equal size pieces, you've then established that each one of those pieces is a 1. Each one of these, come on, pen. Each one of these is a 1/8. So you first took the whole, cut it up into 8 equal pieces, and identified each of those pieces as a 1/8. That, my friends, is what a 1/8 is. Like, think about this. A 1/8 is a thing. It's a quantity. It's an amount. It's a number. What is this number? What is this thing that you say is 1/8? It's an amount that you obtain when you take a whole something. Could it be a whole rectangle? Could be a whole circle? Could be a whole anything. When you take a whole and cut it up into 8 equal parts, each of those individual parts is a 1/8. So fractions require cutting, or the fancy word is partitioning. Whoa. And also this. Now, a 1/8 is also this. If you take one of those 1/8, the whole cut up into 8 equal parts, and copy it 1, 2, 3, 4, 5, 6, 7, 8 times, so I call that copying, or the fancy word for that is iterating. To iterate means to repeat over and over and over again, copying. So when you cut the whole up into 8 equal parts, you get 1/8. And when you copy that 1/8 8 times to get 8 1/8, that's what a 1/8 is. Cutting and copying, partitioning and iterating. Now you can likewise take a whole and cut it up into 3 equal parts. Each part is called a 1/3. And then you can copy that 1/3 as many times as you like. You can have 1 1/3, you could have 2 1/3, you could have 3 1/3, you can even have 4 1/3. You can have as many 1/3 as you need. Now, when you have this idea of fraction, you can now imagine things without just out of 4 out of 3 makes no sense. How do you have 4 out of 3? See, that doesn't make any sense. But can you have 4 copies of 1/3? This is the important thing. When you see a fraction, your brain is thinking this. 4/3, what I'm thinking of is 4 copies of 1/3. In fact, what I would encourage, what I do encourage teachers to say to their kids when you're learning about what fractions are is you just start saying it that way. When you see this symbol, students should say, oh, that's 4 copies of 1/3. And then as they learn and get more comfortable, more efficient, then you can shorten that to say 4 1/3. And then you can shorten that and just say 4/3. You see? You can do that with any fraction. Remember that original 3/8? The original 3/8 was this bar right here. 3/8. At first, I would want students to say, oh, that's 3 copies of 1/8. And by the way, 1/8 is what we got when we took a whole and cut it up into 8 equal parts. Each one of these parts is a 1/8. I have 3 of those 1/8. I have 3 copies of 1/8. I have 3 1/8. I have 3/8. All right, now I want to back you up for a minute. I want you to come back to here. Do you remember when we took this bar and we were told that this represents 3/8? And so maybe a strategic move was to cut that up into 3 equal parts because we wanted to think 3 1/8. So this is a 1/8, this is a 1/8, this is a 1/8. But watch this. Not only is that a 1/8, oops. Not only are those 1/8, but watch this. If I didn't tell you that that was a 3/8 and all I did was take this one bar and cut it up into 3 parts, wouldn't you also, or couldn't you also think of these as 1/3? So these things are simultaneously 1/3. Oops. Just want to get a different color. These things are simultaneously 1/8 and 1/3. And you're going to see this throughout this module or this unit on fractions. It's a crazy thing. In this context, 1/8 is the same thing as 1/3. Did you catch that pause? That was a dramatic pause because 1/8 equals 1/3. Man, if you were showing this to somebody right now, you'd be like, what class are you taking? That 1/8 equals 1/3. You should drop that class because that guy's crazy. Okay, let me finish. 1/8 of the whole rectangle. Come on. 1/8 of the whole rectangle is this thing right here, right? Is the same as 1/3 of the original blue bar. Now, do you see it? When you take the original blue bar and cut it up into 3 equal pieces, each piece is a 1/3 of the blue bar. But if you extend it out to 8 copies of 1/8, then it's 1/8 of the whole rectangle here. And now you wonder why fractions are so hard. But this is what we have to embrace. You guys, we have to embrace this right now. That we have to be flexible in our thinking to recognize that that could be a 1/8 or that could be a 1/3 depending on the whole unit. See? If we were talking about the fraction 1/2 and all we talked about, we just kind of left it vague and said 1/2. 1/2 of what? Watch this. I'm going to give you 1/2 of the money. Well, what money? I'm going to give you 1/2 of the money that's in my pocket. I have 4 cents in my pocket. I'm going to give you 1/2. I'm going to give you 1/2 of the money. I'm going to give you 1/2 of the money that's in that vault over there, jam-packed full with $100 bills. And I'm going to give you 1/2 of the money. Are you catching my drift? 1/2 all by itself is not a full understanding. 1/2 of what? See, 1/3 of this blue bar is 1/8 of this full rectangle. 1/8 and 1/3 are representing the same thing depending on what you're considering the whole. All right, I got to keep going here. So we built that. So describing fractions requires, if I put this all together, describing fractions requires partitioning, So partitioning is this idea of cutting. We're going to take, for instance, a 1/8. A 1/8 is the amount we get by taking a whole and cutting it up into 8 equal parts and taking one of those parts. And iterating. 1/8 is the amount such that 8 copies of that amount put together make a whole. And together, it's not like these are independent things. They kind of work together. 1/8 is the amount we get by taking a whole something and cutting it up into 8 equal parts, and you're imagining one of those parts. And if you copy that part 8 times, you'll make a whole. All right, now, I would like it, and we're almost done, but I want you to pause the video, and if you were to describe 5/8 based on what I'm thinking, with the partitioning and the iterating idea, what would it sound like? Say it out loud to yourself so your ears can hear it. Pause the video and talk to yourself. 5/8 is what? Maybe you even want to draw it. Did you pause? Are you sure you paused? I'm waiting for you to pause. Okay, here it goes. 5/8 is 5 copies of 1/8. That's what it is. And 1/8 is the amount we get by taking a whole and cutting it up into 8 equal parts, and taking one of those parts is 1/8. We have 5 of those 1/8. And then, so the focus there is on the partitioning or the cutting, and then iterating. 5/8 is 5 1/8, where 1/8 is the amount such that 8 copies of that amount put together make a whole. We just happen to have 5 of those 1/8. We do not have a whole yet. Now, again, I'm not saying that partitioning and iterating are separate. They overlap. You're going to see a little bit of partitioning when you talk about iterating, and you're going to see a little bit about iterating when you talk about partitioning. But I want you to see that in the partitioning, the focus is on cutting it up. And in the iterating, the focus is on the copies of. But bottom line, 5/8 is 5/8, 5 copies of 1/8.